Hey pre-calculus students, this is the second video. This is a review of our standard NCN B4, which is the modulus, argument, and interpret them in polar form. All right, so modulus and argument are the big priority. Polar form is pretty straightforward once we have it. We have a formula for the modulus. We have already used it. From our reference sheet, the modulus of a number is the square root of a squared plus b squared. And then the argument, we know what that represents, the angle, the counterclockwise angle of rotation from the real axis. So we always got to, once we know that's what it is, we can always get an estimate if we don't know how to calculate it exactly. All right, so I'm going to do the modulus work in red. I'm going to do it over here on the left side. It says find the modulus of that number. Here I'd say my a is going to be a -2. My b is going to be a -5. It's just the coefficient. It's the number attached to the I. It's not the I itself. So then I'm going to plug it in. Modulus of z1 equals square root of -2 squared plus -5 squared, which is going to be, that's going to be 4 plus 25, which is going to be 29. And we could approximate that if we'd like with a decimal. Approximately equal to, let me check square root of 29 in the calculator. Square root of 29, square root of 29, 5.39. Approximately 5.39. Great. Either answer is fine. You can leave it as a square root or you can write it as a decimal. That's fine. Now I'm going to do my work for argument in blue. The first step I want to take for finding argument is always going to be draw a picture. So I want to draw where my number is. That'll help me a lot as I find its argument. So there's a little axis. This is just a sketch. Nothing has to be perfect. In green, I'm going to plot my number. It's at -2, so a little bit over. Oops, that's a really big. -2, it's a little bit over. And -5, so it's down quite a bit. So I'm going to just plot it right down here, z1. And I always draw its vector going out to it. So the argument we said is the counterclockwise angle of rotation. So I'm going to go from the real axis. So I'm going to start at my real axis over here. I'm going to rotate all the way around till I get to my number. This angle that I labeled here, that will be my argument of z1. As I'm looking at this though, I'm like, what I need to find, the only part I don't know, I know that this up here is 90 degrees in that first quadrant, 90 degrees in the second quadrant. I'm missing this little piece right here. I'm going to call it x for right now. So that's the piece I'm missing. I'm going to zoom in on this. I just need to figure out what that is. So step 1, draw a picture. Step 2 is pick the angle and make the triangle. So once we've gotten here, we picked out, we're like, I really wish I knew what x was, that little piece right there past my negative real axis. If I knew that, I could figure out the overall argument by just adding 90 and 90 or adding 180. Right? And I made a triangle. Let me label the sides of this triangle. On top, I know it's, let me get rid of some of this so we can see a little better. On top, I know it's 2 units over and 5 units down because the coordinate was -2, -5, so it's 2 units over, 5 units down. Now, I need to use tan -1, or inverse tangent of opposite over adjacent. So again, on your formula sheet, there's the formula for this, but I know my x is going to be, the angle is going to be inverse tangent of opposite. The opposite side of my x, if I again zoom in here, the opposite side is across from it. It's going to be 5. So 5. And then the adjacent side is the one right next to it, which is 2. So having a picture really helps us identify what's opposite, what's adjacent. If I put this in a calculator, I'm going to put this in a calculator live. I'm doing it right now. inverse tangent of 5 divided by 2. So I put it in my calculator, and it just gave me the number 1.19. But I should be thinking to myself, no, that can't be right, right? This angle, if I look at it, that's a pretty big angle. It's like more than 45 degrees. So I should be checking myself and being like, my calculator's giving me the wrong value. It must be in radian mode. So I hit mode on my calculator, went over to degree, do it again, and it gives me 68.2, approximately 68.2 degrees. That sounds a lot better. Great. So we're not quite done. Our last step is going to be add/subtract. Could you get the door, Jordan? Add/subtract to get arg. And that will be just writing the argument plus 5. It'll be taking our angle x and adding up the 90s like we'd originally thought. So over here, we're going to have, I'm just going to write my argument down here. The argument of my z1 is going to be equal to, we said this was 90 plus 90 plus, now we found it was 68.2 was our x. So 90 plus 90 is 90 plus 90 plus 68.2 degrees. Doing this, checking this in calculators, 180 plus 68.2. We get 248.2 degrees. Great. So we found a value for our argument. Found our modulus, we found our argument. Awesome. Now step 2, question 2, asks us to write it in polar form and then explain why they represent the same number. Again, polar form is from your note sheet. On your notes it says z in polar form is going to be the modulus of z times cosine of its argument plus sine of its argument times I. So I just wrote generally what the polar form was, and we just have to figure out what pieces we need to plug in. Well, we need to plug in the modulus and the argument. Those are the only unknowns. But in question 1, we found our modulus and argument already. So writing it in polar form is really just finding the modulus argument, then plugging them in. So z1 in polar form will be its modulus, which I'm going to leave it precise. I'm going to say it's square root of 29. You could have also written the 5.39 here. Then times cosine of our argument, which is 248.2 degrees, plus sine of 248.2 degrees times I. So that would be it in polar form. And then as it says, explain why the rectangular and polar forms represent the same number. All right, our rectangular form, I'm going to write it down here, was z1 equals -2 minus 5i. So these basically just give us two different ways of thinking about our complex number. In the rectangular form, it says -2 minus 5i. That means go left 2, go down 5. In our polar form, it gave us a modulus and an argument. That's telling us rotate 248.2 degrees and then go square root of 29 units from the center. Those are two different sets of instructions, but they take us to the same point, right? If I go back up to our picture and looking at the red marks, it says go left 2, go down 5. That takes us to our green point. And then if I rotate 248, so I follow that blue arrow, if I rotate that far and then I walk out square root of 29 units or 5.39 units, that also takes me to my green point. So to wrap this up, I'm going to write in green what we could say here is like polar and rectangular forms are just different instructions to get to the same point. And we could talk about how like rotating, we could be more specific and say, well, rotating this far and moving that far from the center is the same as just moving left 2 and down 5. But I'm happy if we just kind of make a note that we understand that they're just different ways of saying go to that green point in the complex plane. All right, so down below there's a few practice problems where you're doing 3 things. You're finding modulus, argument, and then you are putting them in polar form. So try those out, and then in class you'll see solutions so you can check yourself. And then that'll be evidence that you've done some prep and can get some extra credit on your test. All right, see you next time.